This is the whole database in Excel that I built and I shared it out right before this webinar to give you a preview. And today, what I'd like to attempt is to go from this blank spreadsheet and to reconstruct that big database, and while taking you through step by step and to provide my commentary and explain and to talk like a professor. Hope you can learn something from me today. All right. Okay. But I realized that to make my life easier and also stay true to the philosophy of AI by hand, I actually sketched out the whole thing I'm going to code today and by hand. So I'm gonna take you through the first step of training the embedding for each word, and then if we have a text that would like to chunk them into individual pieces, and then I would be able to take each chunk and feed them into a sentence transformer. In this case, I have three words in each chunk. Those are marked by green. And then if you scroll down, like each chunk going to be embedded into this embedding vector, which is the vertical column of this embedding vector, just one column. And when we have enough of this, and then we just end, which our destination today is to pull them all into a vector database. And down here looks like a table and with different chunks and embedding. And then eventually we'll be able to support application, which is to take a query, which is also a chunk, 3 word in this case, and then get a query embedding. I'll be able to compute similarity using cosine metric and be able to find eventually get the top K in this case too. All right. So this is the roadmap of what I like to accomplish, and hopefully I will be successful. And but since it's live, you will see me making mistakes throughout, and so and then it's just then to all can learn from my mistake as well. All right. So the first step I'd like to be able to do is to tell you what embedding means. So I'd like to get this things called the word embedding. That's all in this orange stripe over here. And so over here, you can see my mouse over here. So I turn on the cursor location. You can see where my cursor is at. And so before I go further, I've shared this exactly this blank Excel sheet on the website, and the website is by-hand.ai. You could download this version. If you'd like to follow along, you can, or you'd like to skip ahead to see what's to come, you could. I encourage you to download this Excel sheet. You can open it up yourself too. All right. And so in this I also share the code that I is intended to build. Anyway, going back to train embedding, my goal for this step is for this, I want to have a list of words and sort it. And each word I'd like to have 1, 2, 3, 4, 5. 5 number to represent the word. And each word will have the 5 number over here. Okay. So that's my goal. And so this step is a bit more warm up. You are not familiar. You're probably very familiar with Excel already, but so this is warm up before we get harder. So first, uh, I'm going to copy this long text into this box. So to train embedding, typically we have a corpus of a lot of text, and then today in this tour example, we're gonna just copy and paste this. And because Christmas season is coming, so I just found this write up some random text about Christmas. Christmas brings joy, love, and warmth. Families gather, sharing gifts, laughter, and stories by cozy fires, and so on and so forth. And then to use this text to train the embedding, so this is a very simple natural language processing 101. And again, it's a warm up, but just add that to familiar with, just to show you and practice coding a little bit in Excel. So for first step, I'd like to break it down into individual tokens. Instead of just one really long string, I want to break down the token. In Excel, I can use this text split, which is the function I will use. And I'll go here and select this. And then I would like to not breaking down into columns. I like to break it down into rows. So I skip this. And there's a row delimiter. So I use a space. So this is gonna give me a bunch of the same words. I mean, the individual word in my training text into a column. So this one. And I did claim that a little bit if you notice that. And here, laughter. Can you see this laughter? Laughter has a comma and then have some kind of period. I want to remove them so that I just only get a word. Okay? And then so for instance, for twinkle, I want to get twinkle, just twinkle, not twinkle, comma. All right. So in Excel, it doesn't have a very good function to do that, but the way I like to use is I use substitute. So I can use substitute and select this one, and I want substitute all the period to nothing. So they'll get me do this. If I test this picture, test this, I copy this and going to this, where do I have period? Here, warms. So you can see that warms period become warms. So clean that a little bit. And then if I can do more is I want to also clean up. If I copy over here to twinkle, it doesn't quite work. I have to substitute doesn't take more than one word, so I can do this nested substitution again. So and I will do this time. I want to substitute all my comma with like nothing. So this is will remove comma and also period. So you can imagine that somebody will write lots of this text processing routine in order to do cleaned up. Another thing I can do is that instead of if I use this one for the first word Christmas, maybe I like this to be all lowercase, so I add lower at the very end. Okay, so this is still very Excel 101 that you've probably done this before. Nothing too new about this, but it's more than review. Okay, now I get this Christmas. Lower warms is periods is removed and period commas are removed. You can do more like you can remove S to do the same, but then it's for this today. We're not. This is not about NLP in steps. So I think this is good enough for me for a clean step. Then I'm going to copy and just paste this, and then okay, it will work. And then then I can paste to the whole thing now, whole column, and go all the way down, all the way down. Oops, too much. Let's go back. That's not what I want to do. That's as the stage is like. Copy over here. Do okay. I copy more, and then I'll copy more all the way to the bottom. Okay, here to this one. This is where I want to stop. Okay, so now I have all of my token cleaned up. So, and then there's some words that kind of repeating themselves multiple times, but I want to get a unique set of words. So this in, turns out it's kind of easy to do in Excel because we can use unique, which is a function, building function. And then I just select this array. Now this time I can go all the way to bottom as the result. So it turns out in this text, it's only a few words that repeat itself. So now I've got a shorter word token, and then eventually I want to sort them. So easier for me to see what words are available. I sort this, select again, select to the bottom, and then this is my sorted tokens. But so this is the vocabulary I'm learning from my training text. And in practice, this training text would be like gazillion uh, documents, gigabytes worth of text. But it still follows a similar process of breaking, tokenizing it into tokens and cleaning it up and normalize them, removing different stems. Sometimes really long work got chopped into different, even smaller tokens that can be done before. All right. So these are text, and embedding this idea is that maybe there's a way we can represent each word into vector. So the first decision we make is that what is the dimensionality of this vector? So say 5. In this case, I just use 5. So I have 1, 2, 3, 4, 5 space reserved. So I can type something like 0.1, 0.2, 0.1, some random number to begin, and before I start some learning process. And for R, I can do 1.2, 0.1. So just we can start with some kind of random number. And in the machine learning algorithm, there are algorithms for training this. And from okay, and so one way I can do this is can do using the random function, and then I just copy my function to the entire block that I need. So this is my there will be 1, 2, 3, 4, 5. Okay, so these are all the different numbers I have here. It's kind of hard to see. Maybe it is not that hard to see. And okay, so this is I have a word embedding. These are random number. I haven't really learned to in learning yet. And so and in Excel, if you use a random number, one thing that I kind of found annoying is that if I say I put another add it somewhere else, all these numbers change. So I like the behavior to stop so I could just comfortably work on it. So the trick I'd like to use for myself is that I will just copy this, copy the whole number, and then I go back up and I'll paste over itself, but I will paste them using spatial pasting. I only paste the values, not formulas anymore. I press V, press values, and OK. So now this number will fix to the value instead of formula. So if I do changes stuff, doesn't change anymore. Now we initialize word embedding with some random number, and the learning process is kind of like this in this way. So for instance, there are some you were trying to find words that are similar in meaning. For instance, share, as they say, smiles is and laughter. There's a smile here, and we have laughter up above. And then you have a training examples, probably like, oh, laughter and smile, they tend to appear in the same sentence. You see it over again. Every time you see it appear in the same sentence, we could say, oh, well, I was just gonna say 0.5 to 0.9, and then I will add smile to 0.9 again, so they are kind of becoming similar, a bit more similar. And they can find another two word, love. Maybe love and memory, should they be similar? Maybe they should. Maybe now just change the number to something closer to each other. Okay. And love, is there anything that opposite? If say Santa, and maybe it's not a good idea. Say shine. I don't have a opposite. Just say just pick any two words. Say I say love and what else? Love and kept. They are not supposed to be similar, but they are two different words. I could just purposely make one minus one. Oh, sorry, not here. Where's my love? Here, one, make it one, but make it another one opposite. Say minus one to put them further away. So you keep repeating this process, so that it's like an intuition behind training this word embedding. That's usually done by large companies like Google, and they'll share on Hugging Face. You can just use this word embedding. But I just want to give you some intuition. That's how word embedding are trained. It's just very simple process. Training, embedding. Take a large corpus, training text, tokenize them, clean that up, got a whole bunch of words that you become your vocabulary. And in here, I have about 200 words, maybe 100 words. But in reality, in practice, you could have 10,000 words or 60,000 words. If you're multilingual vocabulary, you have 200,000 words and so on. And you choose to embed inside. We have 5 here, but in practice, it could be 512. It tends not to be super big. 512 is pretty common here. So that's what we have here now. Now we have this word embedding. Then we have now we talk about application. For now, I want to use this embedding to index a text that I actually do have. So this new text coming from me. Okay, so now I know I have a vocabulary that's from the Christmas. I have some kind of shorter Christmas text that's my text. Christmas, bring joy, love, and warmth. Just actually, it turns out it's a shorter version of the same text. Just pretending this is my text, I want to index now into my own database. And then we'll follow a similar process of tokenizing and cleaning it up. So I'm gonna copy my tokenizing function over here. It doesn't work like that because it was selecting the wrong cell. So I'm gonna move this over to my new text block. So now it tokenized them into this. It's a shorter text, so fewer tokens. And I can also then use cleaned up. Okay, and then I copy my clean text, and then copy over. I copy a formula and copy over all my tokens locations. So that's now I cleaned that all the periods and commas are removed, and everything is lowercase. And you might notice that I skipped sorting and unique because now in the application in indexing, it's okay. Actually, I do care about whether words repeat themselves. I'm not trying to learn a unique vocabulary here. I just use them because I want to index them. I want to put them into a vector embedding sentence transformer, which we're going to talk about. They will transform a bunch of words or vector embedding into a single vector, and I can put it into the vector database here. So that's what I want to do next. So because usually when you take a transformer kind of encoder, so there are some limit into the context length, how many tokens you can feed. For instance, 5,000 tokens or 10,000 tokens. In my very simple sentence transformer, is the limit is 3 tokens, very small, but there's a but it's something I can handle, 3 tokens. So because of that, I have to chuck my input text into the unit of 3 instead, or fewer than 3 too. But in this case, I have a parameter for my chunking, which is that my chunk size is 3 that matches the context window for my sentence transformer size. And then also have an overlap meaning my each chunk. I like to have some overlap. For instance, I gotta free my paint now finally. So if I have chunk, it's like Christmas, bring joy is one chunk. If I overlay, that means my joy, love, and N is another chunk. You can look at in this here. This is my first chunk, and my second chunk is not there. Okay. My second chunk will be joy, love, N. So that's what I like to accomplish. And I have the function called chunk, and I'll say select this cleaned up set of token words. And then my first parameter is chunk size is 3, overlay is 1, and voila, I'm gonna get this arranged in this case. I can play with this function a little bit. So if I have a chunk size equals 0, overlap, and you can see that this Christmas bring joy is without overlap of 1. But if we have overlap of 0, is Christmas bring joy, but love and 1, there's no overlap. Let's go back to my overlay of 1 here. Chunk size is equals 1. So that's my chunking. I break down a list of tokens, a sequence of tokens into a group of 3. Now I have 6 of this, and each one have the unit ID, was it number ID, if the ID 1 all the way to. Now I have 6 chunks in this short text. 6 chunks over here. Okay, so this is chunking. Now it's getting to, we finish warm up. I'm going to get into the hardest part, which is of today's lecture, which is to tell you about a little bit about sentence transformer, and so hopefully I will able to explain this just in a simple enough for you to see. So the overall, my goal is to now have a chunk of text. For instance, what's my first chunk? Is Christmas bring joy, and so I can just type them. But I'm lazy, so I can just use this equal sign to say, oh, this is the same as this 3 cell. Okay, can you see this? All right. So I have Christmas bring joy here, and then I like to do is to look up this embedding from my vocabulary. Where can I find this embedding from vocabulary? One way I can do is that I go to the left here. This is my vocabulary. Okay, so Christmas is, which word is Christmas? I go down my vocabulary and find the word Christmas here. So, and then this is my embedding here. So I can copy this, or maybe not copy this. I want to actually select this. So I select this. I will select this embedding from Christmas. So I'll select here, but it doesn't work. It goes the wrong direction. How can we fix this? So we can use this function called transpose. So I basically want to transpose then into my column vector. So it's what happened here. Okay, so I just did it for one word Christmas. I can repeat the same process of brings and joy. So I have 3 of this. Okay, just try to repeat this process. Just do one more time, just as a review if you didn't follow me. So I'm gonna go find brains. That's why I sorted them. It's easier to find brains right here. And I select this. Okay, now I have this. I repeat the same process. It's in the wrong orientation. So I'm gonna do is a transpose to this. Transpose. Okay, I have 2 of this. Now I can do another one, but I'm gonna write a formula now instead of doing this by hand. But the overall goal is that we have a sentence transformer gonna go through. The goal is to have 3 vertical orange stripes, which represents 3 column vector. Each one is 5 dimensions. Series of transformation. Somehow it became 1 vector with a more dimension, higher dimension space, 1, 2, 3, 4, 5, 6, 7, 8. I decided that I would like to use 8 dimension for my embedding vector. So I gonna go, next is gonna go through the transformation space. And it's a big review or explanation of how very high level, how like neural network work. There's a way that I explain in my class as well. So hopefully that you can learn something from it. And so, okay. All right. So now instead of doing this by hand, I could potentially use the formula to do that. I can do this very useful function called x looked up. So I could, first I want to give a looked up value. I'm going to look up the value on looked up is this token, Christmas. And where do I want to look up? Where's the lookup array? The lookup array is going to, again, shift to the left. It's my entire vocabulary here. So this is my lookup array going down, going all the way down. So this is my lookup array. And what's the return array? Return array will be my word embedding. So it's here. This is my return array. So go all the way down. And then if I do this, you're going to give me this. And I know that it's the wrong orientation. So I can fix this to transpose. Okay. So I transpose this to the right one. Okay. All right. So now instead of picking up by manually, I can use a formula to do this. Look up Christmas, find the associated embedding, and put it right there. So I can do it for brain. It doesn't quite work because the reference got shifted. In Excel, the way to prevent it from doing it is that I want to fix that to the K column. So I'm picking up the vocabulary column, holding my vocabulary words. Similarly, my embedding is from L and P column. So I fix them so that it won't change if I copy over to the right. So let's remove this. Now I'm ready to copy over. Okay, so now I'm getting 3 column vectors. Now I'm doing the first transformation is they go from 5 to 6. How do we change that from 5 to 6? That's what a neural network, linear layer does. Is basically somehow combine them in a way that they could get any arbitrary dimension you want next. So you want to go from 5 to 6, meaning that in this level you have 5 neurons. In next, 5 input, but in this level you have 6 neurons. You need 6 neurons to convert into a 6-dimensional vector. And the way the math works is that it's do a very simple multiplication. And if you just write math, you might see this math in your deep learning class. There's kind of wx plus b equals y, and this Excel allows you to visualize what exactly happening. So what's happening is that this is the matrix I map out. So if I want to transform from 5 to 6, I will have 5, 1, 2, 3, 4, 5. This is my 5 input, and 6 will be 1, 2, 3, 4, 5, 6. This is my output. So it arranged this way. So now I want to prepare this transformation matrix. I copy all the 0 over to initialize to 0. Okay, and then as a proof of concept, I'm gonna put the weight for the first location to be 1, and this weight is going to map to the first dimension in my input. So this is the correspondence. Okay, so if this, I would expect that if after I multiplication, so I will get this number 0.828. So this should be 0.828, and this should be 0.036. This should be 0.842. Okay, that's what I expect my mass to be. And then let's try to implement this. So metric multiplication is quite easy for you to do. M mult, and then I can go select my first matrix over here, and then I select another matrix up here. So this is my input, and the first matrix is my weight, second matrix input. Voila! Get this. This is actually hard to see. Is this 0.828? Let's just hide the ink a little bit for a moment. You can see that 0.828. Come on, 0.828 0. So this is proof of concept is correct. If I do that, so if I move over here, you can see it's copying the second row. If I do that, so this is actually getting the value of third row. So if I do this, 111 is basically summing the first 3 rows to obtain a new feature. Okay, so this is the intuition of linear layer. Let's bring this back up, right? Ink back up, and now in my practice, just usually I just study. Now I got the intuition right, so I just kind of randomly assign one, some weight, or maybe another two here. Okay, so just about some random way assign so that for my simple to work. And every time I do that, you can see those numbers change. Multiplication got revariated. Next, I'm gonna look at the how to add biases. So here I want to remove, I want to add biases so that, for instance, this is 0.461, 0.799. I'd like to add 1, so everything kind of go up by 1. So I can put my biases here. How can we add that so that everything can move by 1 over here? So biases is a good place to put this here. And the 0, 0, 0. I only add bias to my 4th location, or actually 5th location, my 5th neuron. And so the way to do it, I'll go back, update my equation. Maybe I just hide my ink right now. And then I'll add plus, and then I go to the left, and I select. Actually, no, that's not how I want. So I use my mouse to select this column. So this is my weight column. And then you can see this number got moved by 1. So if I put 2, everything moved by 2, move by 3, 0 back to where we are, minus 1, go in the opposite direction. So this is no modification involved here. Let's more adding the biases. Now this number looks scary, and this is my hand sketch looks kind of prettier, a bit less scary. Okay. Now next is activation function. What does activation function do is that I'm gonna bring this back again. So I would like to activate this neuron only if this value is positive. In this case, where these 3 values are negative, I'd like this to be 0, 0, 0. Let's just get back here. So this will be 0, 0, 0. Everyone else will be exactly the same number. That's what Redo does. And then, so to implement Redo, so one way to implement this, if this value, wait, no, I should implement here. If I can select so I can select the whole block. If this is greater than 0, and then I will just select this block one more time, which would return the same thing. But if not greater than 0, which are negative, I set it to 0. So this is the equation. And voila, you can see that all the numbers are the same. Okay, but except for things that are negative. So I'm getting what I want. So there's a logic and philosophy behind Redo. Basically, take any positive number. So I have to go a bit quicker in my commentary. And the next step is that, as you might see, the transformer, the core transformer is attention. So how can we add attention to it? So one way to approximate attention is that we could transpose the token into this way. And then when we do the combination, that will combining them across another dimension, across the position. So basically, I can combine 1, 2, 3 position. We can get a new vector which is based on some combination of vectors from here. So this could be a combination of these 3 in some kind of attention wave matrix. So this is my attention wave matrix, which is also usually a square matrix. So I'm gonna do it very quickly now without a lot of commentary. So transpose, I'm gonna transpose this, pick up my speed, transpose this. Okay, and then I'm gonna have my attention matrix. So now if I have this I'm creating and this is no bias, and then I'm creating a dynamic matrix. So now I do a matrix notation. Realize I'm talk too much. Okay, and then I'm going to multiply this. So I get this, and I'm gonna add my bias term. Go bias term, and my bias here. So this is my attention. Simulate approximately by data transpose. So there's a recent literature how you can run this NLP all the way. So there's a spirit behind this, and I can test it. If I add 1, everything will go by 1. If I start to add more, let's just let's just reset this. I want to show you if we just have identity matrix, there's no biases. This number looks exactly the same, just a transpose. But if I start to add more, or this will allow me to combine them into different words and some biases. So there's a math behind it. But once we, then I can move, kind of transpose them back to this 3-column vector for my 3 words. And then I could run another linear layer to eventually get to my desired dimension. I'd like to move to 6 to 8 dimensions. I'll prepare my 6 by 8 matrix here, and also prepare my bias term here. And then once I do that, I can start to set some random ones, random weight values. So as this example, so when you train this network, usually that's what you do too. You just start with some random weight, and then you run that propagation to update those weight. Now I want to do my matrix multiplication. Select this. Okay, and then also then select this, and then add my bias. So this is my linear layer I just implemented. This is my linear layer, my final linear layer, but we still have to find a way to combine them into one vector before I can output. So to do that is that I will use this transpose trick, transpose them into another orientation, and then I can combine them. Instead of just 3 to 3, I want to be 3 to 1. That's only one row of weight. So if I do 1 1 1 1, what does it do? What it does is that if we do just 1 1 1 1, it means I'm combining them with equal weight, all of them. So they will give me exactly the same result as summing them over, adding them up. Then add another bias term here. Okay, so oh, I forgot to add select. I want to select this, select the, it's my second matrix multiply. Okay, so now if I do this, is you can test this, is thus moving my value, and then eventually transpose back. So I got the form I want to output. So this is my sentence embedding, but it's not normalized. It could be like every arbitrary weight, and so typically I normalize so that by using the L2 norm. The way to get L2 norm is we can add them up, but I want to add the square of each of this number up. So I do a sum square. So sum square. So we have a, for instance, 1 2 1, right? And the normal sum is just 4, but sum square is going to be 1 4 1, which is 6. So this idea, sum square. And then I take a square root of that. That will give me a L2 norm. Okay, and then mathematically, basically, then you take this something square, so L2 norm. Okay, and then once you have that, I could take the whole vector and just weight them by normalize that by, then each one will divide it by this number, this value. And so we'll have this new vector, which is being weighted. And what's nice property about this, that if you calculate L2 sum of this number again, you get 1, add up to 1. So I have a, and then if you do that, I see I have some space for the column vector for other chunk. They will have the same size and also same length magnitude because of normalization, and make comparison a lot easier. You will see in the vector embedding. And while now we have this vector, finally have a first word, what I can do is that I will, and let's just do a split screen here. Now I can skip ahead to my right hand side. Oops, that's not what I'm doing. This. Okay, here. Go up here. Sorry, kind of moving around. So this is what I'm trying to find. Okay, let's just redo this. It's kind of confusing. Let me just do it one more time. So what I want to do is that I can now put into my vector database. Finally, have something to put in my vector database. My first data, first chunk, my embedding. Where's my embedding? That's okay. Now this is where I want to be. I want my embedding. I want to save my embedding to be the vector I just calculate. So first, I can use a split screen, so I could go find that vector. I split this. why is that split here? Okay, I'll split from here. Okay, so now I scroll to the back here. Okay, so this way we were, and we scroll down. So this way we just compute, right? So what I can do is that back to my, I will set this to this guy. So now I put the embedding, but I realize this is not the right orientation. I go back to change the transpose. Okay, I have 10 minutes. Let's do fast enough. And then also I would like to, for that to have my chunk information, go backwards my chunk. So chunk is here. Okay, so now I go back here. I want to set this to chunk here, set the here. Okay, now what I'm doing is that I'm storing this into my vector database in the table and then assign the ID to 1. This is my first chunk. I just finished indexing the first one, and I can do that for the rest of them, which I'll do very quick. The reason why I can do this is that I can copy and paste all this calculation over and then get exactly the same result because we are going to share in this way. And before I can share where I do a little trick is that I have to modify my formula, but I fix the weight matrices, the column, so I can copy them without worry about. I can reuse this weight for my weights and biases. So I'm gonna do it very quick without talking too much. So let me just do it quick. Okay, done. Okay, now I have one more. I have two more I have to do. So I will fix this. Fix my column. Fix my column for my weight matrices and biases. Okay, and then just one more. Fix my column for my. This is my biases. So this is my weight matrix. So okay, now I fix. Okay, this is the most fun thing. Now what I can do is that I could, for my second position, second chunk, then make sure I select enough column. All I have to do is now I just copy. Come on, that's not what I do. Okay, go here. Copy. I want to just make sure I select enough of it. Copy this. Okay, and then I come back here and paste them. Yeah, and then I would see almost like calculation is be copy, except that I have to provide the just make sure I select the right chunk. So I'm gonna do is that this is I'm gonna come back here to select my second chunk, which is here. Okay, now so you can see that all the calculation is inherited, but we'll still copy and we'll get a new set of vectors here. What did I just do? Oh, I accidentally typed something here. Okay. All right. And then I'll do the same thing for my third one. Yes. Now select this. Then yes, enough. Yes. And then copy. And then copy it again. Good. Okay. Now I can do 3 chunks, but I have to do reset the chunk text over here. Select my third chunk, and come back here and select my fourth chunk, and then we reuse all the weights here. And then you can see, check the calculation. You can see that if I select my equation, see the equations, you see the weight matrices and also the input are being selected correctly. And then we'll get this more column vector here now. So now with that, I can go back to my database. I want to index all of them now. So I find the right location. Do here, and I'll split the screen here. So then I'll be able to go back first. I want to make sure I copy all the chunk information here. Come on, maybe I should select over here. All right, so my chunk 2 is here. So now I select my chunk 2 is going to be this 3 tokens. Is it right? No, didn't work. Run one more time. The chunk 2. Select. Okay, select. Okay, good. And then the embedding. This is. I hope there's a faster way to do it. Embedding. I'm gonna scroll down to copy this. There's the embedded for second one. I forgot transpose to transpose. Okay, and then copy here. And okay, it doesn't work. Okay, let's do one more time. Since I'm here, I might just do equals transpose. Then select this. Okay, done. Equals transpose. And select this. So what I'm doing is indexing. Now I'm putting all the embedding for these 4 chunks. But let me just go back here and to select the chunk text. So I can put the chunk text back in the database as well. So whenever I retrieve, I have access to the chunk text. And then if you are familiar with RAG, that's what you do is to then you can put this chunk text into your prompt to provide some extra context. Okay, now I'm done. Finish indexing this 4 chunk into my database. So I still have time. Great. It'll be rushed, but now I can talk about query. Suppose now I have a new query. Well, what do we do with it? So say I have a query, say joy, love, and joy. So this, if you look at this, it's kind of similar to this one, joy, love, and or Christmas bring joy. So how do we look it up so that compute the similarity value with respect to each of this chunk already in the database? So what we can do is hopefully, and then so I will do similar copying and paste here for my query. Okay, I select enough of this, and then copy over here. And but now instead of copying this chunk from earlier, I can just set the chunk to be this query. Okay, now reusing my sentence transformer I just built, and then I have this new embedding vector. Now I go back to the database here. I can put this in this strategic location. I'm gonna tell you why I do that. So I can select this. Then this query is over here. Okay, now I have this query embedding arranged this way. Because if I arrange this way, I'll be able to do is I just do a metric modification with this. For all this embedding and with, and then with this query embedding, a metric modification, because the fact that we already normalize them is this number is actually cosine similarity. You can see that quite similar because we have a random embedding, but in practice it shouldn't be this close. But just as proof of concept, why do laugh, joy, laugh, and which is exactly the same as the second chunk. So you can see this value become 1. Okay? So in cosine similarity value, the most similar, identical, you get higher number. So when we like to get a top K, say 2, how do we get a top K? And we like to go in the particular direction. We want to go descending order, which means that we want to put the highest number at the top and go down as we go. So now we could basically do is we can now sort by function. So I want to sort my array with my ID and chunk. This is my database. Database information. But sort by, now I can sort by my cosine similarity values, which are score that calculated by with cosine similarity with embedding. And then this is the most important decision here to make. Is it descending or ascending? I just talked earlier. This is descending. So I'm gonna do descending. So like this one is -1, and then we do a descending of then while sorting this. So joy, laugh, and which is exactly the same as my query right now, is ranked as top 1. And Christmas bring joy because of joy is top 2. It makes sense. And then at the end, I can add. I only want to take 2 of this. So implement my top 2. But in practice, you will sort millions of records and take like top 2, top 5, etc. But right now, I just take top 2 out of 4. Okay, so this is completed my the whole thing going from, as a little review, what I have managed to do is that we go from training embedding, get word embedding, and chunk them into individual chunk and run them through vector embedding. Somehow take you through the math of a very simple transformer with both the linear layer, also contention, very basic attention mechanism and summarize into a word embedding, sentence embedding with one vector, put it into the database. So one thing and they'll be able to compare them by taking the dot product or match multiplication between each database embedding over here and also query embedding, and able to rank them over here. And you can play with it. Like for instance, I can do joy, so it can get updated. It's all updated live and get different chunks. Okay, so I managed to finish. I'm quite happy about this. Thank you.